Hello everyone. Today we are going to discuss the problem non-repeating element. So it is a easy question. So the question is find the first non-repeating element in the given array ARR of integers, and if there is not present an non-repeating element, then return the 0. The note is the array consists of only positive and negative integers and not 0. That is why the default case is going to be the 0. So if you see in the first example, the input is ARR. So the values are -1, 2, -1, 3, 2. So we can see the first repeating element is -1, 2, -1, 3, 2. So -1 is repeating, 2 is repeating. So the only one non-repeating element is 3. So the output is 3. So in the second example, in the ARR, all the 3 elements are 1. So there is no non-repeating element. So the output is 0. Simple. So the expected time and space complexities are big of n. Furthermore, so company tax. It is asked in the Snapdeal, Goldman Sachs and Adobe companies. So how can we solve this problem? So our approach is going to be, first we'll discuss the things used. So we use there are multiple options, like the approaches are, we can use one hash map, as if we can accept or take the big of n space, so we can use any extra space. So we can use the hash map to count the frequencies and return the first element which is non-repeating, or the frequency of the number is 1. Or another is, we add them to a set, the numbers, and we see while they're traversing, if the set contains the current element, then it means the current element is repeating, so we ignore it. So again, if the number is not present till then and after that whole traversal, so it is non-repeating element. So the simplest, as we discussed many times, the frequency map concept. So we are going to use the same concept here. So our task is to solve this problem is, we count the frequencies of each and every number from the given array, and we check if there is any number which has a frequency of only 1. That means it is a non-repeating element. So the output is the number. So if there is no element with the frequency is equal to 1, rather greater than 1, then the output will be 0. That is the simplest logic. So hash map. So to store the frequencies, we use a hash map, and loops to iterate the array and the hash map. So conditions. Why we are writing these things used means, it is kind of, we need to know these basics or the concepts which I write here, as we can see the hash map, the loops and conditions, before going into this program, so that when we wrote the program, the concepts are understood already, so the logic is now focused, rather than the core fundamentals of the hash map and loops or conditions are not known, and directly jumping into the program. So before going into this program, kindly first get thorough with these 3 concepts, the loops, conditions and hash map. The 3 are the basic. And now, what are the steps going to be used? So step 1, declare a hash map, store the frequencies to the hash map, So these are the steps, only 4 steps. So first we declare the hash map, which is of integer and integer type. So the number and its frequency. So the next step is store the frequencies using a for loop and some inbuilt methods of the hash map of the frequencies of numbers into the hash map. It is the second step. So third step is iterate the array and find the number which has the frequency 1 from the hash map. So if there is any number which has a frequency 1, so it is obviously the non-repeating element. So the output is the number. So if there is no number which has a frequency 1, then the output is 0. This is a simple logic. So step 1 is hash map. So any inbuilt functions or any inbuilt collection framework or all the other things we are going to use here are mostly already imported in their driver code. So we need not to import them again here. That is why we don't see any import statements here. So declaration of hash map is completed. So next step is store the frequencies of numbers into the hash map. So we know to iterate the array we use a normal for loop. So for count we use simply for each loop, which is for integer 1 or n from the array. The n values are going to be, from the first example is -1, 2, -1, again 3, 2. These are the set of values which are going to be initialized into the n variable from the array, iteration by iteration. So what are we going to be do? So we store the frequencies of the n number into the hash map. So how can we put the key and value pairs into the hash map? It is put method. Put method takes the key and value. The key value is n, comma. This is a tricky one. So we can store the frequency using a single line statement which uses a inbuilt method called get or default method. So we use map dot get or default is written in this format because the Java always follows the camel case, in which the first letter or the first word from the name will be a small letter all, and next every word will start with a capital letter. This is called the camel case. So it takes two values again, the key value and the default value we need or we want to keep them. So default value is 0. So when a number is first found from the array, the count will be 0 plus 1 equals to 1. So in the same manner it will be keep on updating with the frequencies. So step 2 is completed using this simple 2 lines or 3 lines. So next one is the iterate the array and find the number which has frequency 1. So how? Obviously for iterating we need the for loop or simply a for each loop. So if for every integer n we find that map dot get of the key value n, if it is equal to 1, then simply return n. Here we didn't use any parentheses for the if condition because any if condition or loop or else condition, any other conditions which are a block statements, if there is only a single statement which we are going to write in that parenthesis, then need not to write the parenthesis to reduce the line number of codes. So the non-repeating element present case is completed. So if there is no non-repeating element, then they set to return 0. So if you run the program, sample test case is passed and the hidden test cases are. So we can see the program passed all the test cases. So if we analyze the time and space complexity, as we know, a hash map, which is a way of variable size, takes a big of n space, and this loop individually takes a big of n. This also loop takes individually big of n. So big of n plus big of n. It is 2 into big of n, and it's also again big of n. So finally by continuously analyzing the time and space complexity, we can be able to find the time and space complexity for our own problems or programs in the future in a better way. So it will be good practice to analyze the time and space complexity. So our code time and space are big of n both. So the expected are also the same. So our solution is acceptable, and we also saw the solution passed all the test cases. So this program link is given in the description. Kindly go and practice the problem. Thank you for watching.